In this movie, we're going to explore the Enter Deed Description located under the Tools pull down. This command allows you to enter deeds, record deeds, plats, whatever, and as you're entering in the data, it is actually annotating it on the screen if you so desire. First of all, let's look at our Plot Deed Description dialog box. The layers for the lines and the curves that it draws, the annotations, and the points, if you so desire points, are all at the user preference. You can change these however you wish if you have particular layers you wanted these items to go to. You have the option to traverse by bearing, azimuth, gon, or points. In our example, we're going to use bearing. You also have the ability for point format. A lot of surveyors at this particular instance in preparing a job actually don't want coordinates or don't want points in a coordinate file, so the point format can be toggled over to none as it is now, and you will not get any points whatsoever on this deed description. If you wanted the complete format, you simply toggle it on. This will give you complete ServCAD points, and it would depend upon your default settings for your point as to whether you're going to be prompted for point number, elevation, and description. The descriptions only option allows you to key in the deed, and at each corner it's going to ask you for the description, and that's all that's going to be plotted on the screen. It's just a description. There's no point number or elevation associated with this. We're going to select none in this example. Our line curve annotations can go on the line in a table, or if you simply don't want any kind of annotations, you can simply check on none. In our example, we're going to leave it on line. The two-table scalar is simply a function for the line and curve tables. Let's say that you had a deed that you were plotting on a 50 scale. Anything, if you set this line type scalar to 1, anything less than 50 would automatically go to the table. In our case, we're going to put it on the line so it doesn't apply. We are going to plot point symbols, and later we will be prompted for the symbol that we want to be plotted at each corner. We are going to store the deed to a file. Now it's going to be a new file, and we're going to name this, let's just say Lot 1, and our deed file name is going to be Smith. There is one already existing. We are going to override it. Now, at a later date, if we wanted to add another lot to this same deed file, the only changes we would make is we would switch from new to append, use the same PDD file that we have, and enter in additional lots. This makes it nice. If you're doing a survey of a subdivision, or you're going to cut out multiple tracts of a large survey, you can have the large deed in one file and start cutting out your lots, and they're all in the same PDD file. So you can draw them all back at once or draw individual lots at one time. We will explore this in a different movie. But right now we're going to go Lot 1. It's going to be in the Smith.pdd file. So at this point we're ready to go. Now we simply select the symbol that we want on each corner. I'm going to select SPT8, which is the open triangle. Now we're asked to pick a point or point number. If we had an existing coordinate file and we wanted to begin a traverse at a particular point and we knew the number, we could just simply key in the number. If we just wanted to pick an arbitrary point on the screen and key in the data and not worry about coordinates, we could do that as well by just picking a point and continuing. In my case, though, I want this to start at 5,000, 5,000 on assumed coordinates. Now, we are keying in coordinates in AutoCAD at this point, so it recognizes coordinates in an X for east and Y for north format. So we're going to key in 5,000 for the east, comma, 5,000 for the north. Now this is about the only time when you're keying in coordinates in ServCAD that you're going to key in the coordinate on the same line. Normally you'll be prompted for a north first, and then you'll be prompted for an east. In this case, I want to start at 5,000, 5,000, so I type 5,000, 5,000 and enter, and here at the lower part of the screen appears the symbol that we selected for each corner. Now we're ready to key in our data. Our first bearing is a northwest bearing. Now the format for entering in data is quadrant and then the degrees, minutes, and seconds. the degrees and minutes and seconds are separated by a decimal point immediately after the degrees. So in our case, first thing, it's a northwest bearing, so it's going to be the fourth quadrant. It is 27 degrees, point 27 minutes and 17 seconds. Enter. Our distance in this case is 50 feet. You can change from feet to chains to poles to barras, whatever the case may be for the particular deed. In our case, it's feet, so we're just going to type in 50 and enter. Now, notice it does annotate the line. We'll zoom in a little bit on it. It annotates it on the fly and shows you what you basically keyed in. We'll do a zoom previous where we can see the input of the whole deed. Now, our next bit of information is a curve. So we simply hit C for curve. It's going to ask us for the radius. The radius is 195. The direction of this curve is left. Notice right is the default value, so we are required to type L and enter. And in this case, it's a non-tangent curve, so we're going to hit N for non-tangent. And it prompts us for our chord bearing. Our chord bearing in this case is a northeast bearing, so it's 1. It's 47 degrees, 55 minutes, and 55 seconds. Enter. Our chord length or arc length. We have the chord length, so we're going to key it in. If we wanted the arc length, we would simply hit A and enter and key in the arc length. Our chord length, however, is 98.39 and enter. And it lays our curve in. Now our next bearing is a northeast, so it's the first quadrant, so it's 1. It's 33 degrees, 19 minutes and 2 seconds. Enter. Our distance for this is 159.76 feet. And enter. And it lays this in. Now we're ready for our next curve. So we hit C for curve. Our radius is 225. It is a tangent curve and it's also to the right, so right is default. We hit enter. And we have the arc length and we also have the delta angle. If you have the delta angle, it's always a good idea to key in the delta angle over the arc length or basically over any of the other information if you have it. So I'm going to hit D for delta and key in a 29.1306. So it's 29.1306. Enter. And it lays our tangent curve in. Now we're ready for our next course, and it's a northeast bearing, so it's 1, 62 degrees, 32 minutes and 22 seconds. Enter. Our distance is 90.41. And our next course is a southeast bearing, so it's the second quadrant, so it's 2. It's 27 degrees, 27 minutes and 43 seconds. Our distance is 181.49. Enter. And now we're ready for a closing course, which in this case is a southwest bearing, so it's 3. It's 62 degrees. It's 32 minutes and 44 seconds. Enter. And our distance is 434.886, so it's 434.886. Enter. And now that concludes our entry of our deed. So now if we hit E to exit and enter, it shows us our closure error, which we're off by 4 10,000ths. That's just excellent. And it shows our bearing in order to force a perfect closure. It also shows our closure precision, which is actually 1 in 2.5 million almost. The total distance traversed was 1,130 feet. So this basically is what you would get with plot deed description. You actually get your geometry drawn on the screen, your lines annotated if so desired, points in a coordinate file if you want, or just point symbols on the screen, or none of the above. You can enter the deed without any annotation or point symbols whatsoever. Now, this concludes the entry of a deed using no points whatsoever. Just to give you an example of the difference, if we went back to points and entered deed description, and we'll just key in one call maybe. Now we're going to change. We're going to say I want complete points, and I want my annotations on the line, and I simply hit again. Now notice what it's done. It's automatically switched us to a pen revise on our specified deed file name, which is what we want, and we'll say this is lot 2. So we'll just simply hit OK, and we'll pick a point on the screen this time. We'll key in this same bearing here, the first call. So we pick a point here. Notice we're prompted for elevation. So in this case, I'll say 100, plot or deed description, IPF maybe, enter. And we're also prompted for a coordinate file. Well, we'll say this is new, and we'll name it Smith, and say save. And here's our first point. Now we're prompted with the same prompts. What is our quadrant? It's the fourth quadrant. It is a 27 degrees, 27 minutes, and 17 seconds northwest. So we hit enter. A distance of 50 feet, enter, and here's our first bearing. Now notice what it's doing on our command prompt. It's asking for a point elevation. Well, if the point elevation in this case we knew was 115, or if we didn't know one, or if we wanted to accept the default, which we're going to do now, we're just going to hit enter and accept 100. The point description may be a stone or set stone, and we can key it in and enter. Now what this is doing is actually writing it to the screen as well as putting it in a coordinate file. So in this case, we're just going to hit, at this point, we're going to hit escape to kill the command. And if we go to points, list points, the 2 points that we keyed in plot deed description are located in the coordinate file. And that's just another method of entering in a deed description, this time with complete point format. The other ways, as we mentioned before, are simply, if we went to none, we did that first. If we went to descriptions only, all you're going to be asked for or prompted for are these descriptions like IPF and set stone. That's all that's going to be there. The point number, the elevation attribute are not going to be there. And it will not be stored to a coordinate file unless you have complete coordinates or complete points toggled on. Create radius points for your curves. If you toggle this option on, when you key in curves, it will actually create the radius point based upon the mathematical information for the curve. This concludes our Enter Deed Description movie.